Hello, math humans. We're going to do 4.5 and 4.6 today. We're going to be graphing trig functions. So specifically today, we're going to do sine, cosine, tangent, secant, and cosecant by hand. So as we get started, we need to go back and review some vocabulary words. A periodic function is a function that has a repeating pattern. Amplitude is going to be the top minus the bottom divided by 2. And period is going to be one complete pattern. So I've drawn our basic unit circle, and I've labeled the 4 quadrantal angles, and then I have labeled their coordinates. So if I want to graph y is equal to the sine of x, and then I want to graph y is equal to the cosine of x, I'm going to graph our ordered pairs, because remember that in the ordered pair xy, in trig on the unit circle, that translates to be the cosine of x and the sine of x. So if I graph sine first, just because, okay, I'm going to put these 4 quadrantal angles. So here's 0. I have pi over 2 pi, 3 pi over 2, and 2 pi. Notice that the y values are going to bounce between a positive 1 and a negative 1. At 0, the y value is 0. At pi over 2, it's 1. And then at pi, it's 0. At 3 pi over 2, it's a negative 1. And then at 2 pi, it's also 0. So this is one complete cycle for the sine function. And then if I graph cosine, again, it's coming from my unit circle, so this is 0. This is pi over 2, pi, 3 pi over 2, and 2 pi. At 0, cosine is 1, so cosine starts high, negative 1. At pi over 2, cosine is 0, negative 1, 0, and then 1. So the cosine function starts high and finishes high. The sine function starts low and finishes low. So now what we're going to do is we're going to talk about how we would graph sine or cosine by hand, and we're going to talk about the generic equation. So it's going to be a sine b x, or it would be y is equal to a cosine b x. A is going to represent, technically it's a vertical stretch or shrink, but when we're talking about periodic functions, we call it the amplitude. B is going to equal, technically, it is the horizontal stretch or shrink. But in these equations, when we're talking about trig functions, B is going to represent the number of cycles, meaning one complete pattern, by 2 pi. Okay? All right, we have a handy-dandy little equation that says the period, and for sine and cosine, I'll write that underneath, for sine and cosine, that means that the period is going to be 2 pi divided by whatever the value of b is. As we start talking about how to do the graph, I'm going to tell you how to do 5 numbers. So we're always going to graph 5 numbers per cycle. So 5 numbers per cycle. The first thing that you're going to do is you're going to calculate the period. Okay, and remember that that equation is 2 pi divided by b. The second thing that you're going to do is you're going to divide the period in half, and you're going to plot that point, and then you're going to divide the period, except I spelled it wrong, in half again. And the second time you divide it in half, that's going to be what I call the counting fraction. And then you're going to plot your points, okay? So every time we graph sine or cosine by hand, we're going to graph 5 numbers. So let's just start with our first example. So we'll do example number 1. And I want to graph y is equal to 2 sine 3x. And so then I'm just going to walk through this process that I've just written down. The first thing I'm going to do is figure out my period. So my period is going to be 2 pi divided by b, which is 3. And so that means my period is 2 pi over 3. Okay? Then I'm going to divide that in half. So 2 pi over 3 divided by 2 is going to be pi over 3. And then the next I'm going to do pi over 3 times half again, and that's going to be pi over 6. So if I put that information on a graph, and I want to graph 2 cycles, the directions on your problems will often tell you how many cycles they want you to graph. My amplitude is 2, so I'm going to put an amplitude of 2, and here's my negative 2. I'm going to put my period on the graph first, so this is 2 pi over 3. I divide it in half, pi over 3, and I divide it in half again, pi over 6. This is what I call the counting fraction. When we're graphing trig by hand, you don't have to reduce your fractions. So this is 1 pi over 6, 2 pi over 6. This is going to be 3 pi over 6. And technically, this would be 4 pi over 6, which reduces to 2 pi over 3. And I am going to draw a line in a different color just to show you where the end of the first period is. And then I'm going to draw a horizontal line so that my graph might not look quite so hideous. I'm going to continue counting by pi over 6. So this was 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, and then this is 8 pi over 6. 4 pi over 6 times 2 would be 2 complete cycles, so I'm going to draw the end of my second cycle. So then remember that sign starts low, so it's going to go low, high, cross, low, finish, high, cross, low, finish, and then I connect all my dots, and then there is my beautiful sine graph. Alrighty? So that one was pretty easy and pretty straightforward. The key is you're always going to calculate your period first, plot the period, divide it in half again, put your amplitude on the graph, and notice that I plotted 1, 2, 3, 4, 5 points per period. So the expectation is that you will graph 5 points per period. So if I do my second example, I'm going to graph y is equal to a negative 3 cosine pi over 4x. So the negative means that I'm going to have a reflection across the x-axis. So if we think about that, instead of cosine starting high, that means when I reflect it, cosine is going to start low. Okay? This is my amplitude, and then this is going to be my b. So the formula is still y is equal to a cosine bx. Now it just looks a little bit different. So the first thing I'm going to do is figure out my period. My period is 2 pi divided by pi over 4. A fraction divided by a fraction means multiplied by the reciprocal. So I have 2 pi over 1 times 4 over pi. The pi's cancel, and I get that my period is 8. And that's okay. It doesn't have to have a pi as part of the period. So if I graph, and again, I'm going to graph 2 complete cycles. So here's my line. I'm going to put an 8, and then I'm going to put a 16, because 2 complete cycles should stop at 16. I'm going to do it in a different color so you can see where I divide it. So 8 divided by 2 is 4, divided by 2 is 2. This one is my counting fraction. So this is 2, 4, the middle point is 6, 8. That's the end of the first cycle. And then 10, 12, 14, and this would be the end of the second cycle. My amplitude is 3, so I'm going to put a 3 and a negative 3. And remember, we have to reflect it, turn it upside down, so that means cosine's going to start down here. I'm going to draw my horizontal line, so maybe my graph won't look too horrible. So I'm going to start here, cross, low, cross, finish, cross, low, cross, finish, and then all I'm going to do is connect my dots, and then I have a pretty cool looking graph. All right, so notice again, I labeled my 1, 2, 3, 4, 5 points, 1, 2, 3, 4, 5. I labeled my amplitude, and then I connected the curves. All right? So as we recap this particular section, so I'm going to put a little recap. For sine A sine BX and y is equal to A cosine BX, the period, one complete cycle, is going to be 2 pi divided by B, alrighty, and this is the key to your graphing. And then we will graph 5 points per cycle, okay? And that's graphing sine and cosine. We're not going to translate graphs. You really only need to have a generic idea. If you want to do any of the graphing in your calculator, the sadness is it won't give you the special values, so you'll want to be able to do that by hand. There are times when we will need to use our graphers to graph our trig functions, and if that happens, we would do a zoom 7, and we would have to have our graph in radians. Otherwise, your calculator will not graph a trig function. Otherwise, it turns out to be a straight line. So the next type of functions that we're going to graph are tangents. So if I have y is equal to A tangent BX, the formulas are all about the same. But tangent has some very particular attributes. Number one, the period is going to be pi divided by B. So notice that the period is half of what happened for sine and cosine, meaning that one complete cycle is going to happen by pi, okay? And then on tangent, I have asymptotes. Hopefully you remember this from previous math courses. So the asymptotes are going to be pi divided by 2b. So when we're graphing tangent, I suggest that you mark your period. Tangent has less points. And then the next thing is half of the period is going to be a vertical asymptote. So I think the easiest way for us to graph this would just be to start with an example. So this will be example number 3, and we're going to graph y is equal to the tangent of x over 2, okay? So in this one, tangent is interesting. We'll talk about the amplitude of tangent in a minute once we sketch our graph, but you really don't have to put the amplitude on the graph. My b in this case is going to be 1/2. So just like with sine and cosine, the first thing I'm going to do is figure out my period. So it's pi divided by b, so it's pi over 1/2. So the period is going to be 2 pi. My asymptotes are going to be half of the period, so it is the period divided by 2, which is what this formula says, so that's going to be pi. So now as I put that information on my graph, okay, so if I put 2 pi, then at pi, I'm going to have a vertical asymptote, and so I'm going to do pi, 2 pi. My asymptotes are kind of like my counting fractions. Here's 3 pi. So now I'm going to actually put a negative pi on here just because of the way that the tangent curve develops. So here's the curve, and then here's the curve. Notice we said that the period was 2 pi, and notice that I have 1, 2, and then the cycle repeats. So notice that my period or my graph repeats after 2 pi. When you're graphing tangents, the asymptotes are going to be your period. Alrighty? Okay, so let's go ahead and do just another one of these. So this will be example number 4. So I'm going to change those values real quick. Alright, so let's do y is equal to the tangent of 3x. Okay? So if I graph tangent, the first thing I'm going to do is find my period. The period is pi divided by b, so the period is going to be pi over 3. The vertical asymptotes are going to happen at half of the period, so I'm going to multiply by 1/2, so I'm going to get pi over 6. And then I'm going to graph 2 cycles. So I'm going to draw my little graph. It doesn't matter exactly where you start, just because of the way the curves look. I tend to start here. So there's a negative pi over 6. Here's pi over 6. There's my asymptotes, okay? And then my period, so 1 pi over 6. This is 2 pi over 6, which is pi over 3. 1 pi over 6, 2 pi over 6. This would be 3 pi over 6, okay? All right, notice that my vertical asymptotes are happening at the odd multiples of the pi over 6. And then I can draw my curves, and they would be there. Alrighty, and then technically if there were another point over here that would have that. But notice at this point that I've drawn 2.5 cycles, but 2 cycles would have stopped at 3 pi over 6. Alright, so tangent's actually way easier to graph in my opinion than sine and cosine because you have less points to plot. So typically with tangent, you're only going to plot your vertical asymptotes and then your period, and that's it. So now let's jump to the graphs of y is equal to a secant bx and y is equal to a cosecant bx. So these are unique also. They're really cool graphs. So notice, remember that secant is the reciprocal of cosine. And cosecant is the reciprocal of sine. So when we graph these, we're going to sketch the graph of the reciprocal relationship. So sketch the graph of the reciprocal. And then, key piece, then we are going to sketch secant and cosecant. So secant and cosecant are superimposed over the graph of sine and cosine. So for example, let's graph this one. Let's graph y is equal to the cosecant of x. Okay, so cosecant is the reciprocal of sine. So I'm going to graph 2 periods of sine. Okay, so sine is, I have pi over 2, pi, 3 pi over 2. Actually, I'm going to do just 1. I lied. Okay, so, and remember that if this is 1 and this is -1, sine would be very light in here. Okay, and I'll do y is equal to cosecant in turquoise so that we can see what it looks like. Remember that if this is y is equal to the cosecant of x, cosecant is undefined when the sine of x is equal to 0, because this equation is y is equal to 1 over the sine of x. You can't divide by 0 because the world would explode, and so when sine is 0, cosecant has a vertical asymptote. Well, notice that that happens here, that happens here at pi, and that happens at 2 pi. So instead of memorizing where it occurs, if you just sketch sine, then you can superimpose the graph of cosecant on top of it. Cosecant's curves would be here and here, alrighty, and so just like with sine, the period for cosecant is going to be 2 pi divided by b. The amplitude is interesting because notice if the amplitude is 1, then cosecant goes up and cosecant goes down. Interesting thing also to notice about cosecant is that it has no x-intercepts. Sine has x-intercepts because that creates the vertical asymptotes for cosecant, but cosecant actually never crosses the x-axis. Okay, and I'm just going to put this in my handy-dandy grapher just to show you what the graph looks like. I'm going to check and make sure I'm in radians. So I'm going to clear what's there, and I'm going to do 1 divided by the sine of x, and I'm going to do a zoom 7, which is zoom trig. And then this is going to be my cosecant graph. okay? Again, the easiest way to graph it is to graph it by hand, graph sine, and then superimpose the graph of cosecant on top of it. So that's actually kind of cool. Alrighty. So now let's talk about, actually let's just do our next example. So we'll do example number 5, and we want to graph 2 cycles, and we want to graph y is equal to the cosecant of 3x, okay? All right, so again, cosecant is the reciprocal of sine, so I'm going to do sine first. So my period is going to be 2 pi over 3, okay? And then I'm going to divide that in half, and that's going to be pi over 3, and I'm going to divide it in half again, and that's going to be pi over 6. So I'm going to sketch my curves, okay? So my period was 2 pi over 3. We're going to do 2 of them, so I'm going to go ahead and put that on the graph. Half of 2 pi over 3 is pi over 3. Half again is pi over 6. This is my counting fraction. So 1 pi, 2 pi, this is 3 pi over 6. And I'm just going to draw a line so we know that's the edge of the first period. 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6. This is the 8 pi over 6. So this was 4, 5. I'm just going to label this one 6 pi over 6. Okay. So sine, my amplitude is 1. So here's a 1 and a negative 1. Sine starts low, high, cross, low, finish, high, cross, low, finish. So I'm just going to lightly sketch sine. My vertical asymptotes are going to happen everywhere that sine crosses the x-axis. Okay, so I have a bunch of vertical asymptotes. And then I'm going to superimpose my curves on the top. So here would be cosecant, this is cosecant, this is cosecant, and this is cosecant. So it's actually really easy to draw or to sketch, but it's significantly easier if you graph sine first. Well, if that's the way we graph cosecant, the way that I graph secant is virtually the same. So A secant bx. Secant is the reciprocal of cosine, so this would be the same thing as doing 1 over the cosine of x, okay? So secant's graph is going to be superimposed over the graph of cosine. So I'm going to start by graphing cosine, okay? So if we start, let's just say we graph y is equal to the secant of x. So I'm going to start by graphing cosine. So I'm going to do 2 cycles. So if this is 2 pi, because the period for cosine is 2 pi, so the period is 2 pi for secant. Okay, here's pi, and then pi over 2, and then 3 pi over 2. This is the end of the first cycle, or period, and then I have 2 pi. This is 1, 2, 3, 4. This is 5 pi over 2, 6 pi over 2, 7 pi over 2, and then 8 pi over 2, which is 4 pi. Okay, so my amplitude is 1 and a negative 1. Cosine starts high, so high, cross, low, cross, finish, cross, low, cross, finish. I'm going to sketch very lightly because I don't have a pencil handy. Here's my cosine curves, okay? Everywhere cosine crosses the x-axis, secant is undefined, so I'm going to have a vertical asymptote here, and here, and here, and here. Notice again, I don't need to memorize that information because I can just get it by graphing the graph of cosine, and then my curves, just like with cosecant, are going to be superimposed over the curve of cosine. Notice again that the secant graph is never going to cross the x-axis, and the amplitude is really kind of weird to report because it starts at 1 and goes to positive infinity, and it starts at a negative 1 and goes to negative infinity. All right, so the last particular topic, oops, I'm sorry, let's do one more example just to make sure that this is well covered. So we'll do example number 5. I think that's the number that I'm on. And I want to graph 2 cycles of y is equal to the secant of 3x. So again, the first thing I'm going to do is calculate my period. So it's going to be 2 pi over 3. And then my amplitude is 1. Okay, secant is the reciprocal of cosine. So I'm going to graph 2 cycles. So here's the first one, 2 pi over 3. Half is pi. Half is pi over 6. 1 pi, 2 pi, 3 pi over 6. I'm going to just draw a light line. That's the end of the first cycle. And then this was 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6. This is 8 pi over 6, which is 4 pi over 3. That's the end of the second cycle. My amplitude is 1. There's a negative 1. Cosine is high, cross, low, cross, finish, cross, low, cross, finish. So this is my sketch of cosine. I'm going to draw my vertical asymptotes. Okay, so they're everywhere that cosine crosses the x-axis because you can't divide by 0, and that's what an x-intercept is. And then I'm going to superimpose my curves on the top of cosine. So that's actually really an easy graph to draw. You do have to differentiate between what I'm grading and what I'm not grading. So that would be kind of what I would expect to see when you take a test. All right, so last little bit of information would be, we'll do it as an example to illustrate a point. I want to solve graphically. Occasionally, when we have trig equations, it is really too difficult to do. So that's the cosine of 2x minus 5 is equal to a negative 3. And I'm going to do it in the interval from 0 to 2 pi. Okay? Sometimes these are too hard to solve by graphing and then finding the points of intersection or the x-intercepts. So instead we do it graphically. So I'm going to graph 2 equations. So I'm going to graph 3 cosine 2x minus 5. And then for my second equation, I'm going to graph a negative 3. I'm going to set my window to go from a 0 to 2 pi to make sure that I only get the answers in this particular interval. So as I bring in my handy-dandy calculator, I'm going to go to my y equals, and I'm going to do 3 cosine. It already opened 1, 2x minus 5, and then my second equation is a negative 3, and I'm going to change my window to go from 0 to 2 second pi, and then the rest of it I kind of don't care about. My y min and max, you can't see it because of the glare. I kind of don't care about either. So now I'm going to do graph. So here's my cosine curve from 0 to 2 pi. Okay, it's important that you change your window so you don't get too many solutions. And then notice down here, it appears that those are the solutions. So I'm going to do second calculate 5 for intersect, and I use my down arrow to get to the horizontal line because that's easier. I'm really anal. I like to start on the left, so I'm going to hit enter, 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 and one more time enter, and notice that I get x is equal to 0.929. And I'm going to zoom, see if it'll zoom on that point, okay, because I want to show you what's actually happening. There was the bottom of that curve, and there's the line going through. And so it's hard to tell if if I'm looking right here, so quit, graph, so second calculate 5 for intersect, trace the straight line because the shortest distance between 2 points is the straight line, enter, enter, enter. Okay, and notice that it's only 1 point. So I wasn't sure if there was maybe possibly 2 points of intersection and it was hard to see. So then I would go back and do a zoom 3, enter. and I would go back and get my equation, and then I would find my other points of intersection, okay? Because there were 2 points of intersection, then I would go back and find the second. So occasionally when we're doing trig, if it says solve, it'll either tell you to solve graphically, or it'll just say solve. If it doesn't tell you how, and it's a complicated equation, then I can use my grapher to help me solve. Remember, in that situation, zoom 7 or changing the window so that you only see the interval where you're trying to find the answers. All right, that is it for